Welcome to the GEM video training series. My name is Jana Latovsky and I'm the Data Team Supervisor. In this video, I will explain how to use the APS data quality syntax to format and check your APS data for errors, either during or after data collection. The data quality syntax is a set of SPSS syntax files created by the GEM data team. They allow a national team to check the APS dataset and prepare it for submission to GEM, after the results are recorded in the APS data input template. The syntax replicates most of the quality checks conducted by the data team, such as identifying formatting errors, incorrect values, or missing data. So by using it, you can help ensure that your APS data will be approved. Teams are strongly encouraged to use this resource to check their results both during and after data collection, in order to detect any issues that may compromise the final sample. But please note, while the syntax shows if there are any problems, it will not correct them, so all changes and revisions have to be done independently. This is why you should never save your APS dataset after running any of these SPSS commands. Just use these files as a diagnostic tool. There are three main data quality syntax files. This video will focus on the first, which checks for formatting issues and the sample distribution. Let's take a closer look at the instructions, commands, and outputs you'll find in this file. There are two main sections. First, there are some general notes on formatting your APS data. Please carefully read these to comply with all GEM standards. Remember, if there are any problems with the final dataset, GEM sends it back to the team for revision, so it's important to resolve all the issues before submission. Then, the syntax allows you to automatically check some basic formatting, such as whether your ID values are correctly created and demographic value labels defined, as well as to check your weights and sample distribution. First, you can run these commands to make sure that the unique ID number assigned to every respondent is within GEM limits. Our only requirement is that it is no longer than 9 digits, so if it is, you will see an output table that indicates how many ID values are too long. This example shows that there is one ID value above 9 digits, so you would have to identify and revise this value in your dataset. The next set of commands is used to find any duplicate IDs. If there are no problems, the output table will designate all cases as no duplicate. But if you see a count of one or more duplicates, these values must be revised. To find which IDs are repeated more than once, you can run the next line of code. And the output will show these values at the top of a list of every ID in the sample. Here you could see that an ID of 109 was assigned to 2 different cases, so one of these must be changed. Next, you can check those demographic variables for which you must define value labels. If the output shows an undefined value, such as the 4 in this example, you must add a label to explain what this number represents. Then, there are several opportunities for you to check your computed weights. We require that all weight values have an average of 1. So first, you can simply run the means command to verify that your weight is scaled correctly. If the mean is not equal to 1, please revise your weights. Next, we give you the opportunity to check your unweighted age-gender distribution. First, you can run a command that creates a 7-category age variable that you will use to check your sample. Then, you can run this crosstab command to look at each age group by gender, and produce the following table. The next step is to copy the unweighted distribution into Table 1 of Worksheet E1 of your APS survey report. Note that there are 2 sets of tables, one for 18 to 64 and one for 18 to 99 samples, so use the side that applies to you. Then scroll down to Table 4 in the same worksheet. This will show you how much your collected sample deviates from the ideal in each age-gender category. This is based on your provided national population statistics, so these must be entered into the designated area in Worksheet D of the survey report in order for this table to be populated. If any of the cells turn red, this means the deviation is problematically large. This table, for example, shows that a sample had 13% fewer males ages 25 to 34 than we would expect based on the population. Finally, you can scroll down to see if the overall deviation from the sample is acceptable. If the summary cell in this table is red, then the sample is considered unrepresentative by GEM standards. The last step is to check your weighted age-gender distribution, following the same method, but first applying the weight variable. This output is then entered into Table 2 of Worksheet E1, and the corresponding Table 5 is checked to see how the weighted sample distribution differs from the ideal. If the weights are correctly created, every cell here should be green. The overall deviation from the ideal should be green as well, meaning that the weights have correctly adjusted for any over or underrepresentation in each age-gender group. So this is the formatting data quality syntax. To learn more about the data quality syntax files in general, and for a detailed overview of the values and skip logic syntax files, please watch the other 2 videos in this series. Thank you for taking the time to watch this training video. If you have any questions, please contact me or the data team, and we will be happy to help.